This question is called Russian Roulette series. It has like several parts. So start off with the first part. It says, let's play a traditional version of Russian roulette. A single bullet is put into a six-chamber revolver. The barrel is randomly spun so that each chamber is equally likely to be under the hammer. Two players take turns to pull the trigger, with the gun unfortunately pointing to at one's own head, without further spinning until the gun goes off and the person who gets killed loses. If you, one of the players, can choose to go first or second, how will you choose, and what is your probability of loss? So this is like traditional Russian roulette. We have, let's say, it's like the chamber, and then there's like six bullets, 2, 3, 4, 5, 6. Like 1, 2, 3, 4, 5, 6. So let's say like I'm player A, and there's also a player B. If I'm player A and I go first, then I will be at risk of dying from chamber, like bullet number, like, or what is this like slot called? Like chamber number? I don't know. But like, anyways, like I'm at risk of dying if the bullet is at slot 1, 3, and 5, right? Because I go first, I shoot myself with the first potential bullet. If it's empty, then the next player, player B, shoots himself on the second potential bullet, bullet number 2. If that's empty, then I go again, I shoot myself with the third potential bullet. If that's empty, then they go with the fourth, I go with the fifth, and they go with the sixth. So if you go first, your risk of death is if the bullet is in slot 1, 3, or 5. So player A risk if bullet is in 1, 3, or 5. Player B is at risk if the bullet is in slot 2, 4, or 6. And the bullet does not change its spot after each spin. So let's say it gets set somewhere. Then if it's set at an even slot, then player B will lose. If it's set at an odd slot, then player A will lose. And the chance that goes into an even or an odd slot is 50% because there are half the slots are even, half the slots are odd. And therefore, the chance of winning or losing in a fair game of Russian roulette with the bullet does not move after its initial placement is 50%. So again, the bullet gets placed into an even or an odd slot. If you're player A, you will lose if it's in an odd slot and win if it's in an even slot. And going into an even or an odd slot is equally likely for either scenario, and so the chance of winning is 50-50. Okay, now let's change the rule slightly. We will spin the barrel again after every trigger pull. Will you choose to be first or the second player, and what is your probability of loss? So now it's different. Now it can be, now no matter when we pull the trigger, the probability of loss will always be 1/6. So for any given pull, for example, if you go if you shoot first, right, in the first scenario, your probability of death is 1/6. Then when the second player goes, the probability of death is 1/5, right? And so in this case, the previous rule does not impact the current shot attempt we're on. So every spin has the same probability of 1/6. Now we can say that P is the probability that player A wins. Player A is the first to shoot. Okay, so we can say we have some letter P, and that represents the probability that player A, which is the first person to shoot, wins. Now we know that if every shot is equally likely to kill somebody, and player A going first means they're at risk one extra time, then logically player A is at a higher risk than player B. So now we have that like set aside. We have to keep that in the back of our minds as we solve this question. So we can solve this by saying, so we start, right? And with probability of 1/6, so probability of 1/6, we die, right? We're player A. Or we can say we lose. Same thing, right? We can say A dies, lose. Or probability of 5/6 that we go again. That we continue, right? Put the 5/6 here. In the circle, I write continue. In this case, the 1/6 chance that A dies, then what's the probability of A losing given A dies? Or probability of A winning given A dies is 0, right? 0% chance of us winning if we die on the first turn. If we continue now, again, now it's player B's turn. If it's player B's turn, then again it can be a 1/6 chance of B dies, and therefore we win. And the probability of us winning in that case is 100%. Or we can just say 1, right? Decimal form, this is 0. And then in this case, if we continue with probability of 5/6, now we're back to where we started. Every probability is the same going forward, right? Probability, again, it's 1/6, 5/6, but now it's our turn again. And so we're in the exact same spot we were back here, right? We just go back to where we started. So this was 1/6, and this was 5/6. So, and when we go back to where we started, our probability of winning goes back to P, right? If we go first and we die with a 1/6 probability, then in that case, our probability of winning is 0 because we died, right? We can't win if we died. In the other case, in the 5/6 case, we survive, right? And from that point on, now it's player B's turn. If they die with a 1/6 chance, then we win. We're guaranteed to win, so 1. There's a 1/6 chance that B dies, and if B dies, we win. If we continue again, we're back to where we started the first time, on the first time we pull the trigger, because it's our turn again, and every shot attempt is independent. And that probability we said was P. Right? This is prob of A winning and prob of A winning. And again, here is prob of A winning. So now we can represent this as an equation. We can say the probability of A winning, there's a 1/6 chance, it's just 0 off the bat. There is a 5/6 times 1/6 chance that we win. 5/6 times 1/6 times 1, and this was times 0, plus 5/6 times 5/6 that we reset back to the probability of our winning being P again. So 25 out of 36, probability being P. This cancels, so we can say P equals 5 over 36 plus 25 over 36 P. Yeah, and then we can subtract by P from both sides, or 25 over 36 P on both sides, to get 11 over 36 P equals 5 over 36. And so P equals 5 over 11. So the probability of winning, if you go first, is 5 over 11. And so we would like to go second, right? Because then our probability of winning is 6 over 11 and our probability of losing is 5 over 11. So we're favored to win if we go second. So go second, P win, 6 over 11, P lose, 5 over 11. So now it says, if instead of 1 bullet, 2 bullets are randomly put in the chamber, your opponent played the first and he was alive after the first trigger pull. You are given the option whether to spin the barrel. Should you spin the barrel? So the chamber has 2 bullets. We go second, and the first player pulled the trigger and didn't die. So if we had like 2, 3, 4, 5, 6 bullet slots, and they pulled this trigger and didn't die. Now, if we don't spin, right? If we don't spin, we are excluding ourselves the possibility of landing on this empty chamber. And so we would like to spin, right? If they pulled the trigger and that slot they shot was an empty slot where there was no bullet, if we don't spin, we remove the chance of ourselves from being able to land on that slot. Because now no matter what, we just go from here. And so if there's 2 bullets left, there's 1, 2, 3, 5. There's 5 slots and 2 bullets left. So if you don't spin, your chance of death is 2/5. Right? There's 2 bullets and 5 slots. If you spin, you unlock that empty bullet slot, and you guarantee you're to not have that a bullet be in there. So the number of bullets stays at 2, but the number of empty slots, or number of total slots, it goes up to 6 now. So it's 1/3 versus 2/5. And 1/3 is a better chance of survival. So you want to spin. Okay. What if 2 bullets are randomly put in 2 consecutive positions? If your opponent survived his first round, should you spin the barrel? So again, 1, 2, 3, 4, 5, 6. They shot, and this bullet was not a killer bullet, so it was empty. Now we know these bullets are consecutive, right? That means they could be in this batch, they could be in this batch, or this batch, right? They could have also been in this batch, but since that bullet has already been fired, and we know that if it's already been fired, then the bullets next to it, like these bullets can't be consecutive. Like they can't also be in these 2, like the bullets can't be side by side along these 2 bullets because they're connected by this bullet, which has already been fired. And so now, the bullets can be in these 2 slots, right? These 2 slots, or these 2 slots. There's 4 possible slots the bullets could be in, and there's 1 possible slot the bullet could be in out of 4 overall slots remaining. And so that means that if we don't spin, our probability of death is 1/4. However, if we draw this out again, 1, 2, 3, 4, 5, 6, then the bullets, there's just 2 bullets somewhere in this chamber and 6 slots. So if you spin, your probability of death is 1/3. Because it could be in these 2 slots, 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 1, 2, 3, 4, 5, 6 total slots. One of those possible slots have to contain a bullet, and so it's one. Oh, sorry, two of those slots could contain the bullets. So there's 2 out of 6 chance. 2 possible slots, right? Because the bullet could be here, right? And if it's there, then the slot and this slot are susceptible of having the bullet inside of them. Yeah. Or more simply, 2 bullets left in 6 slots, high risk. And so in this case, you don't spin.